Okay guys, so we've been factoring and a lot and practicing it a lot, so let's talk about why we actually factor. So we use factoring in order to solve equations, and let me remind you what we did last semester. If I wanted to factor something like this, and I would do the greatest common factor, so each of these can be divided by x, and remember we put the x in front, and then whatever we get after we divide by, we put in parentheses, and that's still equal to 0. Well, the whole purpose of factoring is so that I could set each factor equal to 0. So I'm going to set x equal to 0, and then the x plus 9 equal to 0. So when we do that, that helps us get the answers to this equation. So I get two answers here. I get x equals 0 and x equals negative 9. All right, so for example, if we were doing the difference of two squares on this one, remember difference of two squares is square root of x squared, and then the square root of 121, and our parentheses would be x plus 11 and x minus 11. So what do we do with those parentheses? We set them equal to 0 and solve. So we have two answers, x equals negative 11 and x equals positive 11. Okay, one more just to remind you how that works, and then we're going to move on. All right, so here I would subtract 6x on both sides. Remember, we want to get everything on one side equal to 0. Okay, so in this case, the equation isn't already equal to 0. And then we would say, okay, what two numbers multiply to give me negative 16, add to give me negative 6. So that would be negative 8 and positive 2. And then we set each factor equal to 0 and solve. So our two answers are x equals 8 and x equals negative 2. All right, so that's review from last semester. All right, so in the last video, remember we combined factoring methods, and so when we were doing something like this, we said always check for the greatest common factor first. Okay, so what can I divide all of those by? Well, that will be x cubed. So x cubed goes on the outside of the parenthesis, and then remember, if I do x to the fifth divided by x to the third, remember I'm going to have two x's left. It's like I'm subtracting those exponents. And if that doesn't make sense, remember if I have x to the fifth, that means x times x times x times x, whereas x to the third means x times x times x. So I'm canceling three x's in the top and bottom, so that's why I only have two of them left. Okay? So I've got x squared plus 6x minus plain old 7, because all the x's cancel on that one. Okay, but now I still have to factor what's in the parentheses. So now I'm going to do the other kind of factoring, and that's where we say what two numbers multiply to give me 7, negative 7, add to give me 6. All right, so that's going to be positive 7 and negative 1. Okay, and I still have this x to the third power in front. So now I'm going to have three things to set equal to 0. So I'm going to have x cubed set equal to 0, x plus 7 equal to 0, and x minus 1 set equal to 0. Now if I solve for x cubed, I'm going to do the opposite. I'm trying to cancel the cubed, and that's doing the cube root. Okay, so cube root of 0 is just 0. And then subtract the 7, I get x equals negative 7. And add the 1, and I get x equals 1. So here I'm getting three answers. And then we'll save this factoring for in class, so don't worry about that for right now in your notes. Okay, so a new kind of factoring that I want to show you, it's called U substitution. It's when we set u equal to x squared. And this is very useful. So after you've checked for the GCF, after you try finding the greatest common multiple, greatest common factor, I mean, then use this when you want to factor anything with an x to the 4th power. Okay, so after you've done all the GCF and you still have x to the 4th there, then we have a way that we can deal with that, even though we have never really done x to the 4th. So here's how that works. Okay, if I'm going to have u represent x squared, that means that I can rewrite x to the 4th as x squared raised to the 2nd power. So x squared times itself would be x to the 4th, right? So if I had x squared times x squared, okay, that would be the same thing as x to the 4th. Okay, so that's what we're doing there. Here, I mean, this is just 4 times x squared. And in the last one, there is no x squared, so we don't have to worry about that. So you see where I have all my x squareds. Well, anywhere where I have an x squared, like here and here, I'm going to replace that with the letter u. Okay, so instead of having x squared raised to the 2nd power, I'm going to have u raised to the 2nd power. Instead of having 4 times x squared, I'm going to have 4 times u. And then on the last one, this is still going to be minus 12. So why would we bother doing that? Well, from here, this is so we can factor like normal. We know how to do this kind of factoring. This is like what we did last semester. So here we're going to factor like normal. So I'm asking myself, what 2 numbers multiply to give me negative 12, add to give me 4? Okay, so that's going to be positive 6 and negative 2, right? So if I have that, then I've been able to factor like normal, and that's factored, right? It's just I had the letter u instead of the letter x. So how does this help us? That's not really our answer. So now I've got to go back and replace any of the u's with x squared. Okay, so instead of, I'm going to go back and everywhere where I see a u, I'm going to go back and replace it with what I originally replaced it with. Okay, so instead of u, I'm going to have x squared. Here, instead of u, I'm going to have x squared minus 2. Okay, the only other thing you have to watch out for is, can you still factor anything? Okay, so here's where you want to look for any difference of 2 squares, like the one that we did in the beginning of this video. Okay, so if I look at these, this first one, that's not a difference, that's addition, right? So I don't have to worry about that. Now this one is subtraction, so that's a difference, but 2 is not a perfect square. If I take the square root of 2, I'm not going to get a whole number. So that's all I can do, and that's as far as I can factor. So I've taken something that we've never been able to do before, and I've made it very doable just by using u instead of x squared. So let's do that again. Let's see how that works with this one here. So what's the first thing we should always do? We're always going to try a GCF. So what can I divide each of these by? Well, I can divide that by 9. Everything can be divisible by 9. And then the highest power of x, you see how this one has an x squared. So I can divide all of these by x squared. Okay, so I'm going to have 9x squared in front of the parenthesis. And then the 9's cancel in this first term. And then I have x to the 6th over x squared. So again, I'm subtracting those powers. So that's going to give me 1x to the 4th. All right, here I'm going to have 18 divided by 9 is 2. And then x to the 4th divided by x squared. Remember, I'm subtracting those powers. So that's just x to the 2nd power. And then here, negative 27 divided by 9 is negative 3. And then the x squareds cancel, so there are no x's left over. Okay, so I've done the GCF, and you see how I still have x to the 4th power. So when you see that, that means we're going to use u is equal to x squared. Okay, so I'm only working inside the parentheses right now. So remember, this is where we said, okay, I'm going to have x squared raised to the 2nd power. This is 2 times x squared, and this is still just minus 3. So I'm going to replace anything where I see x squared with u. Right, so instead of x squared here, I'm going to put u to the second power. Instead of x squared here, I'm going to put u, and then this is minus 3. So how do we factor this? This is, again, what two numbers multiply to give me negative 3, add to give me negative 2. So this is going to be u minus 3 and u plus 1. And then what did we say we do after that? Well, now we got to go back in and replace. Okay, so now we got to replace u with x squared. Okay, so anywhere where I see a u, I'm going back and substituting in x squared. Okay, so can I do a difference of two squares? Well, here's the difference right here where I see x squared minus 3, but if I do the square root of 3, that's not a perfect square. So I can't factor that anymore. The only thing I have to remember is remember that 9x squared in the very beginning. We need to bring that down. Even though that wasn't really part of our factoring with the u, that's still part of our answer. So that is going to be my final answer there. All right, so on the back, we are going to do that in class, okay, because that's a little bit longer. All right, so make sure you bring these notes to class. It's very, very important.